Ever wonder how the incredibly complex software we use every day, the apps on your phone, the OS on your computer, is actually built? Well, a huge piece of that puzzle is a powerful idea called object-oriented programming. And trust me, it's not nearly as scary as it sounds. So let's just dive right in and see how it all works.
To really get why this concept is such a game changer, let's start with a big question. If someone told you to build a complex, interactive digital world from the ground up, where would you even begin? How do you manage all of that mind-boggling complexity?
See, the answer is that just writing endless lines of code isn't going to cut it. To build something that's stable, that can grow, and that you can actually understand later on, you need a plan. You need a blue plan. And that simple idea right there is the key to unlocking what object-oriented programming, or OOP, is all about.
All right, so here's our game plan for this explainer. We're going to break it all down. We'll start with the basic building blocks, then get into that core blueprint analogy. After that, we'll see how programmers cleverly hide complexity and reuse their work, and finally, we'll bring the 4 central pillars of OOP all together.
At its heart, OOP is really just a way of thinking. Before this came along, code was often just this long, messy list of instructions. OOP completely changed the game by modeling the real world, letting us create digital building blocks that represent actual things, whether that's a user, a bank account, or even a car.
And to create these digital building blocks, we have to start with 2 fundamental ideas that work hand in hand. Honestly, they are the absolute bedrock of everything else we're about to talk about.
And that brings us right to our main analogy, the relationship between a blueprint and the actual building itself. In the programming world, we call these a class and an object. So, first up is the class. Think of this as the master plan. It's not a real thing you can touch. It's more like a design document. It defines what a house should have, things like walls, windows, and doors, but it isn't a house itself. It's just the idea. And that's where the object comes in. An object is the real thing. It's the actual instance that you create from that class blueprint. It's the physical house you can walk into, built exactly according to the plan, and it has its own specific details, like being painted red or maybe blue.
This comparison really makes the difference crystal clear, doesn't it? A class is the blueprint, it's the cookie cutter, it's the abstract idea. The object is the real house, the actual cookie you can eat, the concrete instance. And that's the most important takeaway here. You design one class, and from that one blueprint you can create many, many unique objects.
Okay, awesome. So we have our blueprints and our buildings. Now, how do we make them secure and easy to use? This is where the first 2 pillars of OOP come into play, encapsulation and abstraction. And really, they're all about managing complexity.
Encapsulation is kind of like putting your valuable data inside a protective capsule. It bundles the data, let's say your account balance, together with the only functions that are allowed to change it. In OOP, we call those functions methods. This whole setup prevents anyone from just reaching in and messing with the data directly, either by accident or on purpose.
A bank account is the perfect example. With a bank account object, the balance is kept private. You can't just reach in and change it to $1 million, right? You have to go through the proper channel, the withdraw method. And that method has important rules built into it, like checking if you even have enough money in the first place. It's security by design. The next pillar is abstraction, and this one is all about simplicity. It hides all the messy, complicated inner workings of an object and just shows us a simple interface to work with. It makes things so much easier to use. Just think about driving a car. You press the gas to go faster, you press the brake to stop. It's simple, right? You don't need to be a mechanic who understands fuel injectors and how pistons fire just to drive to the store. All that complexity is abstracted away, hidden behind a simple dashboard. That's the real power of abstraction. So, we've made our objects secure and simple. Now, how do we make our code really efficient and flexible? Well, that brings us to our final 2 pillars, inheritance and polymorphism.
Inheritance is just a fantastic way to avoid repeating yourself. It lets you create a new class that automatically gets all the properties and behaviors from a parent class. It is the ultimate principle of don't reinvent the wheel.
Let's look at a family of vehicles. You could start with a general vehicle class that has wheels and an engine. Then a car class can inherit all of that stuff and just add its own unique feature, like air conditioning. A bike class can also inherit from vehicle but add handlebars. You see? You write the code for wheels just once, and then you reuse it everywhere. It's incredibly efficient.
And finally, we get to polymorphism. Now, I know it's a mouthful, but it literally just means many forms. And it's this really powerful idea that lets us perform a single action, but have it result in totally different outcomes depending on what object we're talking to.
The classic example is a speak command. You can tell a dog object to speak, and it'll woof. But if you give that exact same command to a cat object, it's going to meow. Same action, speak, but a different result based on the object. This is what makes your code incredibly flexible and adaptable.
So we have covered a lot of ground, but the most important thing to remember is that these 4 pillars, encapsulation, abstraction, inheritance, and polymorphism, they don't just exist on their own. They all work together to help programmers build software that's robust, easy to manage, and really, really powerful.
So let's bring it all home with a quick summary. The class is the cookie cutter, the object is the actual cookie. Encapsulation is like a safe that protects its contents. Abstraction is your TV remote, hiding all the complex electronics inside. Inheritance works just like family genetics, passing down traits. And polymorphism is how one person can take on different roles, like being a parent, an employee, or a friend. The key is just to remember these simple analogies to help lock in these powerful ideas.
And that brings us to the end. But here's the final thought for you. These pillars are not just for code. They are powerful mental models for breaking down any complex system into manageable parts by creating blueprints, hiding complexity, and reusing solutions. So what's a complex problem in your own life that you could start to understand a little better just by thinking about it in terms of objects, blueprints, and hidden details?